All of these different electronic devices are microcontrollers. The things about microcontrollers that distinguish them are they have a standalone processor. So different chips on different boards here provide computing power that allows the microcontroller to make decisions to run some code. In addition, what distinguishes these microcontrollers from computers that we might attach them to in order to program the microcontrollers is that they have inputs and outputs that allow them to interface with the real world so that we can measure what's happening out there in the real world and then have some outputs that will allow us to control different devices so that we can change what's happening in the real world. Now, those inputs and outputs, they could be analog, for example, 0 to 5 volts, measuring all the different voltages in between, or they could be digital. Digital inputs and outputs are either on or off. And if the microcontroller is operating on a 5-volt power supply, then on will be 5 volts and off will be 0 volts. In addition to those analog and digital direct inputs and outputs from devices, there may also be some other inputs and outputs. For example, serial ports, I2C, which is another serial connection specifically for connecting to multiple different instruments at the same time. SPI, which is another serial protocol, again for connecting to multiple different instruments at the same time. And the list goes on and on. And we'll deal with these more complex possibilities a little later in the course. Now, all of the things inside this box, those are all microcontrollers. They're different brand names, they have different processors on them, and they have differing input and output characteristics. They operate on different voltages, but they all are microcontrollers. Now, within the full range of microcontrollers, there's a brand called Arduino. So when we talk about Arduino, that's what's inside this box. These are Arduino. And Arduino is just a brand name. It's a manufacturer. The manufacturer is an open source hardware manufacturer, so the designs for these Arduino microcontrollers are readily available and other people can use them. Finally, the microcontroller that we'll be using in this course is the Arduino Uno, and that's this one right here. And so we're going to zoom in on the characteristics of the Arduino Uno and how it performs. However, a lot of the things that we learn about this package will extend out to other Arduinos and to other microcontrollers. Now, interestingly enough, all of these microcontrollers up here are programmable using the Arduino integrated development environment. That means that we can take all of the coding skills that we learn here and we can apply them in the same environment to write code that will run on any one of these microcontrollers and do some interesting things for us. So let's zoom in on the Arduino Uno. If we look at the board, it's got a plug here where we can plug in a USB cord. That cord provides 5-volt power, and it provides communication with the computer. So if we plug that in, we can program the Arduino right away. This plug over here, it provides an option for providing power separately. Say, for example, we don't have a computer and we just want to run the Arduino standalone. Once we've programmed it over the USB interface, we can apply DC power here, and that will provide the power to run the Arduino. This is an Atmel 328 processor. That's the standalone processor that we're looking at. And its inputs and outputs, the main ones are a whole row of digital input-output pins over here, numbered from 0 up to 13. And each of them have slightly different characteristics that we'll get into. But basically, each of these pins can be at either 0 volts or 5 volts. And if it's an output, That'll be controlled by the processor. The processor will tell each pin what voltage to be, either 0 or 5 volts. Or if we configure it on the processor to be an input pin, then we can connect a wire to each of these little pin sockets, and we'll be able to read from the processor what the voltage is on those digital inputs. Now, the only thing we'll be able to tell is whether it's down near 0 volts or up near 5 volts. And if it's somewhere in the middle, it may be a little uncertain what kind of a reading we'll get. So we use digital inputs and outputs only for things that are on-off situations. And we make sure that we either get up very close to 5 volts or down very close to 0 volts in order to be able to tell the difference between on and off. Now over here on this side, there are 6 analog inputs, A0 through A5. And these analog inputs allow us to measure a voltage. Now the Arduino Uno runs on 5 volts, so we can measure over a voltage range by default going from 0 up to 5 volts. So I could say this is 0, a little bit more than 0, a little bit more than 0, 2 volts, 2.5 volts, 3 volts, up to 5 volts. And we'll talk some more later about the resolution of these analog inputs. But for now, just keep in mind that these analog inputs give us a range that divides for our 10-bit analog inputs into about 1,000 different levels that we can detect. So we can detect fairly closely what the voltage variation is here. So digital inputs for on and off, analog inputs will allow us to measure progressive changes over a whole range and resolve exactly what's going on, like the level in a tank, or what the temperature is in a room, or how fast a motor is rotating, things like that which have quantitative characteristics rather than just on and off. So we'll look in a little more detail at the various pins on the Arduino Uno later. But for now, just keep in mind that all of these microcontrollers fit into a large family of microcontrollers. When we talk about Arduinos, we're talking about a particular brand. And when we talk about the Arduino Uno, we're talking about the particular model that we're going to focus on in this course. And you'll have an introduction to that when you come out to the lab.